If you've ever wondered how geologists know exactly what minerals are inside a rock, or how paleontologists can look at the bone structure of a T-Rex, then you're going to love this video. We're going to deep dive into how thin sections are made and how they can be used. I found these volcanic rocks over here on an island north of New Zealand. I'm going to take one of those along and we can see if Kamen can identify the minerals that are in there. I headed off to the University of Canterbury, where I'm busy doing my geology degree, and met up there with Kamen Engel. He's a geologist and a thin section expert, and he's going to show us today how he makes thin sections.
The first part is we find a section with nice crystals.
Yeah.
And then we take a slice off, so I'll probably do one through the middle here.
And what machine do you do that on?
We use the trim saw.
So kind of like just a lapidary saw?
Yes.
This copper plate over here has got diamond little chips in it.
Yep.
For like 1 centimeter, 2 centimeters down.
Yeah.
Oh, that's cool. After cutting that hand sample to size, Kamen uses this 80 grit lapidary grinder to remove the saw marks and to make sure it's completely flat. This is the side of the sample that's going to get epoxy to the microscope slide, so it has to be 100% flat now because it can't be adjusted later. So that's 600 grit.
Yep.
And how long do you have to do that?
I just do that until it's relatively smooth.
Is it like 5 minutes, 10 minutes?
Probably a minute.
And that's a piece of glass under there.
Yep.
Now that one side of the sample is perfectly flat, Kamen is mixing up a 2-part epoxy that he's going to use to stick this sample onto the microscope slide. This device over here provides a firm pressure onto the samples, and that ensures that the epoxy dries in a nice thin and consistent layer. Here we have a sample already glued to the slide. It takes about a day for the epoxy to harden, so we've moved on to a different sample that's already cured. The sample is now going to get cut down to about 1 millimeter in thickness and then ground down even thinner on this very accurate saw and grinder. The saw blade has to be exactly parallel to that arm that it's resting against, otherwise the sample isn't going to be a uniform thickness. And this side of the machine has got a really precise grinding wheel on it, and Kamen is using it to make it even thinner, getting very close to that target of 30 microns that he has. This very precise gauge over here allows Kamen to see if it's at the correct thickness. He's trying to get it as close as possible to 30 microns as he can. Now you're going to check under the microscope
To see if it's how thick it is.
Okay.
And then if it's far too thick for me to be bothered,
Yeah.
I will chuck it on the machine.
Gotcha.
If it's thin enough, I'll do it by hand.
How do you know if it's too thick?
You go based off the colors. Quartz is usually the standard. If quartz is
Yeah.
grey, that means it's good.
Okay.
But quartz is not even showing colors in this, which means it's far too thick.
Gotcha. This very specialized device uses a strong vacuum to keep the microscope slides in place while it is being ground down to exactly the right thickness. And you're using a vacuum because then there's no resin or anything on the slide at all.
Yeah.
Keeps it clean.
So now it calibrates for the plate dip for the dish. bryozoan and then high-tech stuff, rubber band.
What is that thing at the top?
That's where the grit is. There's grit slurry.
The grit slurry.
It's grit and water. And then we start at low speed and hope that the vacuum holds. You can see it's a bit dodgy.
Yeah. So it should be in green.
Yeah. You can see that's T is the target. We want it to be no dish. That's where we're at the moment. It's very dished on the outside.
Okay. So it should be at 0, but it's at 10.
Yeah.
The thin sections are finished and Kamen has brought me up here to the microscope lab to look at some of his favorite ones. Here's a beautiful piece of dinosaur gem bone.
And pretty much what we're looking at here is, this is calcite. This is microcrystalline quartz, chalcedony. And then in the middle here, that's actually the, I guess the fossilized structure of the bone. So it's just adding one layer of quartz.
That's so cool. By adding this one layer of quartz in, the colors become much more vibrant and it's easier to see if there's any differences in the bone. And here is that piece of basalt. It's been cut now. And this is it under the microscope. The colors are crazy. And look how well defined some of those crystals are. You can really see the edges. And Kamen's identified them for us, and here's an olivine. And another couple of olivines. Some plagioclase feldspars. Pretty much every rock's got feldspar in it. And definitely my favorite ones, these beautiful pyroxenes. So when you go to university, make sure you do Geology 242. And that's where they'll teach you how to use this chart, and this will be one of the clues as to how you identify the minerals, is by looking at these colors. I recently found a really cool bryozoan, and Kamen has made these thin sections for me. Bryozoans are one of the fossils that you actually need thin sections to be able to identify them, because you have to look at the structure of each of those zooids. A huge thank you to Kamen and the university for allowing us to have a look at the process of creating these thin sections. It's amazing how much work goes into each and every one of these. Now you know why the lecturers get really upset when people drop these in class and they break. Thanks so much for joining me, everyone. I hope you enjoyed this little bit of a view into thin sections and microscopes. It's really fascinating. Like, I'm all about fossils, but I've really been enjoying Geology 242, where you can look at all the minerals and the ores under the microscope. Stay safe, and I'll see you on the next hunt.